Okay, so in this video we're going to look at chi-square, which is a non-parametric test that you use when you want to see if there is an association between two or more things when the data is categorical or nominal. So in other words, when each individual data point can only belong to one particular category. So I've opened up SPSS and I'm going to type in data. So if we go to the SPSS datasheet that we've been using, the data we're looking at today is school support exclusions. So here we have data from a bunch of children, male and female, you can see on the left, and we have a number of different data points for them. So we have a variable excluded, which is whether or not the children or that child has been excluded from school. So for the chi-square, initially we'll just look at gender and excluded or not. So I'm just right click those columns and hide them for the moment. So as you'll remember, for SPSS we need to assign numbers for these categories, labels, so male, female, excluded, not excluded. So I'm just going to create two more columns, gender number, excluded number, and I will just pause the video whilst I do the recoding. Okay, so you can see that I have assigned a 1 here in gender for male and a 2 for female. And then in the excluded column I've assigned a 1 for excluded and a 2 for not excluded. So now I can copy and paste these values into SPSS, so I'll highlight them all. Control C to copy and paste. So today SPSS is happy and has let me just paste. So I'll just clear that final set of cells so that SPSS doesn't think there's data missing there. And now I'm going to name these variables. So we go to variable view, and I know that the first one is gender, and I assigned a 1 for male and a 2 for female. And I know that that data is categorical or nominal, so it needs to be marked as such. And in the second variable I have the data for exclusion. Oops. And so I go to values, 1 for excluded, 2 for not excluded. And again the data is nominal. There we go. Okay, so you can see that SPSS has changed the numbers to the labels, and again this is because the value labels is checked. If I uncheck that, you'll see it goes back to the numbers that I pasted in, but I highlight value labels here, check that box, and then it will show the value labels. So in order to do the analysis, first I'm just going to look at the data to see what it looks like before I do any inferential statistics, before I do the chi-square. So we go analyze, descriptive statistics, and we go to crosstabs. So I'll put gender in rows and exclusion in columns, and you'll see what that means when we get the output. Now I do want to see a bar chart, so I'm going to check display clustered bar charts. So we click OK. There we go. So the first thing I'll do is give it a title. And do the same up here. And let's have a look. So first I've got 48 cases and none are missing. And then you can see we've got a table here that shows me the frequency counts. So I've got 18 males who were excluded, 7 who were not excluded, 7 females who were excluded, and 16 who were not excluded. You can see genders on the left. That's because I put gender in rows. So we've got male in the first row and female in the second row. Exclusion I put into columns. So you've got exclusion and then excluded in the first column and not excluded in the second column. And then we have totals as well. So I can see I've got 25 males, 23 females, 23 who are not excluded, and 25 who are excluded, and then that gives me the overall total of 48. Coming down to the bar chart, if I double click on this, then I can edit the axis legends, so I can give this a much more intuitive title. Number of children. Gender I'm going to leave because it's self-explanatory, and I can leave the key because it shows me exclusion and then excluded in blue and not excluded in green, and I'll give the title, I'll give it a title that's a little bit more descriptive. So I've sort of frequency of gender by exclusion because we're dealing just with raw frequency data, so the number of individuals in each category. So then that's a bar graph I could use if I was writing the data up. But we want to know if that is significant. So in other words, if it's really not something we'd expect to occur by chance. So we go back to analyze. We can do this from the output file. We don't need to go back to the data sheet. Descriptive statistics and crosstabs again. So I can uncheck clustered bar charts because I don't want to see one of those. And now we go to statistics and we click chi-square. And we put continue. And then in cells we'll also click on expected. And then we click OK. So now I'll just give this a title. Chi-square gender and exclusion, so I know what it is. And here you'll see the table. Again, it's a little bit busier this time. That's because we've got both the observed counts, so the data we actually got, and we've got the expected counts. So the expected counts is what we would see if the data were just generated by chance. So what would you expect to see if there was no association between gender and exclusion? In other words, if the null hypothesis was true. If we come down to the bottom, we'll see here that it says naught cells have expected counts less than 5. So when you do a chi-square test, if you have small numbers, the chi-square test becomes less reliable. So if any of your expected counts are less than 5, then the chi-square test is less reliable, and you should think about using some other kind of analysis, or actually better, collecting some more data. So there we go.